So I want to spend a little bit of time talking you through the vertical milling machine. It's one of the machines that the WJEC want you to have experience of in engineering. And this is our Walco turret mill, we call it, or a vertical milling machine. When you're using this machine, first thing you need to consider before you do anything at all is making sure that your PPE, your personal protective equipment, is correct. You need to make sure that you've got a face shield on, or at very least face shield. You need to make sure that you have no long hair or jewellery or anything dangling. Make sure you've got tight-fitting cuffs on your equipment and stuff like that. So make sure you've considered all your PPE. Now, next thing, vertical miller. Let's just have a look at the parts of the vertical miller. So I have a bed on the vertical miller which has these T-bolt slots inside it, and that is where I clamp my work. Now, we have a machine vise permanently fitted to the bed. It can be removed, and you can put larger work pieces on there, and you can do direct clamping, which I'll talk about later, to fasten your work down. Let's just have a look at the basic layout. So what we have a powerful electric motor at the back of the machine, which is driven through a set of pulleys. The pulleys are kind of hidden inside an interlock container at the top here, so we can change the speed of the milling machine if we want to. Just close that down and lock it tight. Now that drives through the turret of the machine, a spindle that rotates in a clockwise direction. Now let's have a look. The turret of the machine has inside it a drawbar. That's a long bar which we can tighten and loosen with a spanner at the top of it, and that enables us to clamp a cutting piece in. So I did show you, I think I'll probably show you later on, a range of cutters. So like, for example, a fly cutter. You can change this out, you can remove this bottom section, install the drawbar, drop it down, take your cutter and your collar out, and then swap them out for a different cutter and collar. It takes a few minutes, but it does enable you to do all the range of jobs that you're going to need to do. Okay, so you have a way of clamping your work. You've got the bed of the miller, you've got a motor with a series of gears on it that can turn it around, and you've got a way of clamping your cutting piece. Right, let's have a look at what else we've got. So we have at the moment locked off a handle, which is a way of raising and lowering the cutting head manually, but we don't use that. I'll show you a different way we raise and lower the cutter. Another one for fine movements using a vernier scale at the front of the machine, which is quite handy. But like I say, we lock that off at the moment. And let's have a look at our main ways of moving the job when we're using the miller. So we have something called traverse. You might be familiar with the idea of traverse from say something like climbing. So a traverse is when you move side to side. I quite like to use mathematical terms for this. So I call this my x-axis traverse. And that moves from one side to the other anti-clockwise. Oh, sorry, I'm moving it clockwise and anti-clockwise. There's a handle on either end that you can use. What else have we got? So that has got an automatic feed if you need to use it, which basically powers that across from one side to the other. And we can set a stop to automatically stop. So we can knock that lever over and we can drive it across automatically or drive it back automatically. That's pretty handy. What else have I got? So I've got a y-axis traverse. That moves front to back, and I've got a Z-axis traverse. My Z-axis is the one that raises and lowers the job. The cutting piece stays still. We raise and lower the job to go into it. So all three of these methods of moving are going to be used when you come to do this job. Okay, how do we set these up? Well, as always when machining, first thing you need to do is you need to find an edge. So you touch the surface of the job, and from that point, which becomes our datum, we zero the dials on the traverse handles. Okay, so 0, 0, 0. We know where our starting off point is, and from that point we can start measuring distances that we're cutting either across, down, or up and down into. So that's pretty handy in terms of setting the machine up. Right, what else do I need to go over? Starting and stopping. Okay, so this machine is fitted with an interlock guard. So the interlock guard is very similar to the interlock guard that we have on the lathe, in that the machine will not start when it is open. So if you slide that over, you will hear a clicking noise, which is a little electric magnet activating a solenoid telling the machine it's safe to turn on. So with the guard closed, so I'm just going to get my glasses on now. I haven't got my face shield on because I'm not going to be machining metal, I'm just setting it up. I can now use the on-off buttons to turn the spindle on. So you've got red for on, and you've got, green for on, and you've got red for off. So they are, and you've also got a red button at the bottom, which is your foot switch to turn it off automatically. Now, next job. So when we start machining reel, right, what we need to do, like I said before, we find the edge of the material, we put a cut on, so we bring my Z-axis up, so I'm below the surface of the material. With aluminium, we could probably get away with a cut of about 1 millimetre, maybe a little bit more. So you put the cut on, turn the machine on, and then you're going to do a cut using the X-axis traverse. So you're going the length of the bed of the machine. Now, there's two ways of doing cuts in material. I'll probably have to draw this out on the board for you, but we have a thing called a climb cut and a conventional cut. And you'll feel that one of them will be more juddery than the other. So what you have to imagine is your cutter is spinning clockwise at the moment, and as the teeth of the cutting tool are hitting the material, if you're travelling in a right to left direction, the chips that it's removing are being pulled up and out of the material. Okay. Now the other way of cutting it would be to go left to right, and the machine is still going to be rotating clockwise. Now what this one's doing is it's chomping into the material and it's dragging it chips out below the material. Okay, so we call it climb and conventional cuts, and one of them is trying to pull the material, like this one here, trying to pull the material as you're cutting it, and this is the one that's going to create a bit more of a judder. All right, so try and just listen to that whilst you're cutting, whether you're doing a climb cut or a conventional cut. Some you'd be advised against doing with certain materials. Okay, so here we go. I would drive that cut now across the material nice and slowly. I'm not actually cutting anything at the moment. I cut that material right the way across, and I'm cutting a slot across with my slot drill. And the idea would be I'd make that slot go across and across again, and I would end up making a flat surface at the right angle. So there, let's knock that milling machine off. Bring the guard out of the way so it's safe to use now, and remove my cutting piece. Where's my Tommy bar gone? On the top somewhere, right here. Tommy bar. And hopefully you will end up with something along the lines of this. There is another slot that you've got to cut. You have to cut a slot that fits at the end of this bar here, but I will change the size of the cutting bit before you do that. Okay, so that is the vertical miller.